The minimum burial depth for a 240-volt single-phase electrical service from the power company to a house in Virginia is 24 inches. This requirement is in place to protect the electrical conductors from physical damage, such as digging or other activities that could compromise the insulation and lead to electrical hazards. The National Electrical Code, or NEC, provides guidelines for safe electrical installations, including burial depths for various types of wiring and voltage levels. While local codes may amend or supplement the NEC, the 24-inch depth serves as a general rule for residential services. It is crucial to consult the specific regulations of the local jurisdiction and the serving utility company, as they may have additional requirements or exceptions based on soil conditions, conduit types, or other factors. The burial depth is measured from the top of the conduit or cable to the finished grade. If the wiring is direct buried, meaning it is not encased in conduit, the 24-inch depth applies to the top of the cable itself. When installing an underground electrical service, it is important to consider several factors to ensure a safe and reliable installation. Firstly, the type of wiring used must be suitable for direct burial or installed in an approved conduit. Underground service entrance cable, or use cable, is specifically designed for direct burial applications and has a moisture-resistant insulation. Secondly, the trench should be free of rocks, debris, and sharp objects that could damage the cable or conduit. A layer of sand or fine soil can be used as bedding for the wiring to provide additional protection. Thirdly, the location of the underground service should be clearly marked to prevent accidental damage during future digging or excavation. A warning ribbon or tape can be buried a foot above the cable to alert anyone digging in the area. Fourthly, the trench should be backfilled with suitable material, such as clean soil, and compacted to prevent settling. Settling can cause stress on the cable or conduit and potentially damage the installation. Fifthly, all connections and splices must be made in approved junction boxes or enclosures that are rated for underground use. These enclosures must be waterproof and corrosion resistant to protect the connections from moisture and environmental factors. Sixthly, the grounding system must be properly installed to ensure electrical safety. A grounding electrode, such as a ground rod or a ground plate, should be installed and connected to the service equipment. The grounding conductor must be sized according to the NEC and properly connected to the grounding electrode and the service neutral. Seventhly, the installation should be inspected by a qualified electrical inspector to ensure that it meets all applicable codes and regulations. The inspector will verify that the wiring is properly installed, the burial depth is correct, the grounding system is adequate, and all connections are secure. Eighthly, it is important to maintain accurate records of the underground service installation, including the location of the wiring, the type of wiring used, and the depth of burial. This information will be helpful for future maintenance, repairs, or modifications to the electrical system. Ninthly, before digging, always call the local utility companies to locate any underground utilities in the area. This will prevent accidental damage to underground cables, pipes, and other infrastructure. Failure to do so can result in serious injury, property damage, and legal penalties. Tenthly, if the underground service crosses under a driveway or other paved area, the burial depth may need to be increased to provide additional protection. The NEC specifies different burial depths for wiring under roadways and driveways, depending on the voltage and the type of wiring used. In some cases, it may be necessary to encase the wiring in concrete or install it in a rigid conduit to protect it from physical damage. The NEC Table 300.5 provides detailed information on burial depths for various wiring methods and voltage levels. For residential services, the minimum burial depth for direct buried cables is typically 24 inches, while the minimum burial depth for rigid metal conduit or intermediate metal conduit is 6 inches under driveways and 18 inches under public streets. It is important to note that these are minimum requirements, and local codes may require deeper burial depths in certain situations. For example, in areas with heavy traffic or poor soil conditions, a deeper burial depth may be necessary to provide adequate protection for the wiring. In addition to the burial depth requirements, the NEC also specifies requirements for the type of wiring that can be used for underground services. Underground service entrance cable, or use cable, is specifically designed for direct burial applications and has a moisture-resistant insulation. This type of cable is typically used for residential services and is available in various sizes to accommodate different ampacities. Another option for underground services is to use individual conductors installed in conduit. The NEC specifies the types of conductors and conduit that are suitable for underground use. The conduit must be approved for direct burial and must be installed according to the manufacturer's instructions. When installing conduit underground, it is important to seal the ends of the conduit to prevent moisture and debris from entering. This can be done using duct seal or other approved sealing compounds. The NEC also specifies requirements for the size of the conduit based on the number and size of the conductors it contains. The conduit must be large enough to allow for easy pulling of the conductors and to prevent overheating. In addition to the wiring and conduit requirements, the NEC also specifies requirements for the grounding system for underground services. The grounding system must be designed to provide a low impedance path for fault current to return to the source. This helps to protect people and equipment from electrical shock in the event of a ground fault. The grounding system typically consists of a grounding electrode, such as a ground rod or a ground plate, and a grounding conductor that connects the service equipment to the grounding electrode. The size of the grounding conductor is based on the size of the service entrance conductors. The NEC provides tables that specify the minimum size of the grounding conductor for various service sizes. It is important to install the grounding electrode in a location where it will be in contact with the earth at all times. The grounding electrode should be driven into the ground to a depth of at least 8 feet and should be located away from any underground utilities. The grounding conductor should be protected from physical damage and should be securely connected to the grounding electrode and the service equipment. In addition to the NEC requirements, local codes may also have specific requirements for underground services. It is important to consult with the local electrical inspector to determine the specific requirements in your area. The electrical inspector can provide guidance in the proper installation methods and can verify that the installation meets all applicable codes and regulations. Installing an underground electrical service can be a complex and potentially dangerous task. It is important to have a thorough understanding of the NEC and local codes before beginning the installation. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the installation. A qualified electrician will have the knowledge, skills, and equipment necessary to install the underground service safely and correctly. They will also be familiar with the local codes and regulations and can ensure that the installation meets all applicable requirements. When hiring an electrician, it is important to check their qualifications and experience. Make sure that they are licensed and insured and that they have a good reputation. Ask for references and check them carefully. It is also a good idea to get multiple quotes from different electricians before making a decision. By following these guidelines, one can ensure that the underground electrical service is installed safely and correctly. This will help to protect people and property from electrical hazards and will ensure that the electrical system operates reliably for years to come. Remember to always consult the NEC local codes and the serving utility company for specific requirements and guidelines.